welcome back to my channel Science and Math with Gerald. Today we will be continuing with the chapter that we have started and we will be seeing a next logical connectivity, the third one, and the application of it in the exercise 1.3. So let us see what is the next logical connective. The next logical connective is negation. From the word itself we can justify that we know that it can be a negative statement. So if we are given a statement, the definition tells us the denial of an assertion contained in the statement is called its negation. Very simple. If we are given a statement, a positive statement, then we have to write that statement in the negative form, then it becomes the negation. Let's see what exactly and how exactly are the examples of this. So the first example that I have written is he is honest. I am given a statement P, he is honest, then its negation are of three types. We can write the negative statement in three types. He is not honest. We can write it is false that he is honest. And we can also write it is not the case that he is honest. So we have to justify in the negative form. So if we are given a positive statement, we have to convert it into negative statement. And if we are given it a negative statement, we have to convert it into positive statement. Not convert it, we have to give the opposite of that statement. So let us see the truth table based on that. The truth table, if P is my statement, then the symbol, this symbol justifies negation, and negation of P. If P is a true statement, then negation of P will be false. And if P is a false statement, then negation of P will be true. Exactly opposite. True will give me false, false will give me true. This is what we need to know in negation. And here we will see the exercise 1.3 based on this logical connective. Write negation of the following statements. We are given a few statements in the first question of the exercise. Each statement is given and we have to write the negation of it. So the first statement tells us all men are animals. All men are animals. So simple, the negation of that statement all men are animals will be, if P is all men are animals, then negation of P will be all men are not animals. Or we can also write, or negation P is, it is false that all men are animals. So multiple forms of writing a negative statement. So we write it as all men are not animals. You can write either form of this form. There is one more form we can write, it is not true that all he is honest. So here you can write, it is not true that all men are animals. So any possible way you can use. The next one is a negative statement C. 2 plus 3 is not equal to 5. So the negation will write P gives us 2 plus 3 is not equal to 5. Therefore negation of P will be 2 plus 3 equals to 5. Here if it is not equal, then our negation will be equal. A positive changes to negative, negative changes to positive. 2 plus 3 not equal to 5, 2 plus 3 equals to 5. This is how we give negation of any statement. Now let us see what are the truth values of negations of the statement. So write truth value of negation of following statement. So we will see root 5 is an irrational number. Root 5 is a irrational number, means it is a true statement. So P is true. My P statement, that is root 5 is an irrational number, is true. Therefore its negation of P will be root 5 is not irrational, which means it will be a false statement. If my P is true, my negation of P will be false. So P is true, negation of P will be false. For every x being a natural number, x plus 3 is less than 8, which is not true for all natural numbers. Because once the number becomes x is equal to 6, 6 plus 3 is 9, which is not smaller than 8. Hence, we have to write P, this statement is false Hence, my negation of P will be true. That is what negation is. The simplest of all logical connectives. Understanding simple, applications also very simple. With these basic logical connectivities, we'll see the next two logical connectives in the next video, that will be conditional logical connective and biconditional logical connective. We'll understand these two in the next video. Thank you for watching this video and being with me throughout the video. Stay tuned to this channel and subscribe to the channel for more such awesome and mathematical videos.